So if you're just tuning in, this is actually part 2. Go back and see 7.4 part 1 if you are not sure where the heck I am. But to finish this problem, we have to distribute that 32. So that'd be 32x, and then 32 times 5, handy dandy calculator, tells me it's 160. And then we distribute that 40 times x, and then 40 times negative 2 would be negative 80. So then to solve this equation, we're going to first want to combine those x's, so I would subtract 32x from both sides. So then I would have 160, let's just put down here, equals 8x minus 80. Then I would want to add 80 to both sides so that I can get the x by itself. So that would give me 240 equals 8x. And then when you divide by 8, you get x equals 30. Now I know I went way farther than I was supposed to. So I get that x equals 30. And even though it's really tempting to say, yay, I'm done, you have to remember that we are looking for PS and SR. So you're going to have to plug it back into what you were given. So for PS, we have x equals 30. So this would be 30 minus 2, which is 28. And then for SR, you're going to have 30 plus 5, which would give you 35. So you notice with this problem, it is the triangle angle bisector theorem. And when you set up the proportion, you get a value for x, and then you just have to plug it back in once you get to the bottom. So for these last 3 questions that we have on here, we have to find the length of this segment and the theorem we use to solve it. So this is where we're going to practice getting comfortable with recognizing which ones it's probably going to be. So when we look at this, we want to find JG. So I'm just going to label it as X because that's what I'm trying to find. And with JG, I notice that I have 2 parallel lines. So then I think back, we have the triangle angle bisector theorem. I don't have a bisected angle, so I'm not going to use that one. I also have the triangle proportionality theorem and its converse. So you have to remember the triangle proportionality theorem is the one that when you're given parallel lines, that's when you can find the ratio. So we are given parallel lines, so we know it's triangle proportionality theorem. And we just have to set up the proportion. You can set it up a bunch of different ways. I'm going to set it up 30 over x equals 20 over 11. So we'll cross multiply to solve that. So that gives me 20x equals 330. And when we divide by 20, x will equal 330 divided by 20 is 16.5. And then you just do a quick check. 16.5 is x. What did x represent? It represented JG, and JG is what I was trying to find. So if you really want to, you could also write it as JG equals 16.5, and that'd be totally fine too. Okay. For the second one, they want to find SR and ST. So again, thinking back, I'm not given any parallel lines, which would tell me that I could use the triangle proportionality theorem. I can't use the converse triangle proportionality theorem because none of these lines even look like they're parallel. And then you notice, hey, I have 2 angles and they are bisected. So that tells me I can use the triangle angle bisector theorem. So if you can remember what to look for, you can remember what the name is supposed to be. So it's going to be the triangle angle bisector theorem because those angles are the same. So then we just set up the proportion. So x plus 5, and if you want, I'll do it differently this time. Rather than going x plus 5 and, what was I? X plus 5 and 12.5, we'll do x plus 5 over x minus 5, and then 12.5 over 7.5. Okay, so when we cross multiply, we have 7.5 times x plus 5 equals 12.5 times x minus 5. So when we distribute, 7.5 times x is going to be 7.5x. 7.5 times 5 will give you 37.5. And then you distribute the 12.5x. And 12.5 times 5 will give you 62.5. And that'll be a negative 62.5 because of the negative 5. So then to solve this, we're going to combine our like terms. Let's change the color up a little bit. We'll subtract 7.5x. Boop. And that'll give me 37.5 equals 5x minus 62.5. And then when you add 62.5 to both sides, you get 100 equals 5x. So then x equals 20 when you divide by 5. Now, again, it's really tempting to say, hey, x is 20, I'm done, yay! But you have to remember that you have to plug it back in because SR is x plus 5 and ST is x minus 5. So if I know that x is 20, SR would be 20 plus 5, which would give me 25. And ST would be 20 minus 5, which will give me 15. And then you're done. Okay? Last but not least, we just need to verify that BE and CD are parallel. So your keyword is that we are verifying they are parallel. So the theorem that we're going to have to use is the converse triangle proportionality theorem. If you are trying to prove that the lines are parallel, you'll be using this converse. So we're saying with the converse, if they're proportional, then they'll be parallel. So we have to see if it's proportional, then it's going to be parallel. So we set up our proportion. 12 over 18 equals 9 over 13.5. When you cross multiply, 12 times 13.5 is 162. And wouldn't you know, 18 times 9 is also 162. So since they are proportional, then we know that the lines are parallel. So we have that BE is parallel to CD. And that is the end of that with that converse triangle proportionality theorem. So the homework for today is going to be on page 498, 1 through 4, 6 through 11, 13 through 20. So if you have any questions, remember, we'll do a quick run through. We have triangle proportionality theorem, converse triangle proportionality theorem, and the triangle angle bisector theorem. So remember, triangle proportionality theorem, you're looking for a triangle with parallel lines. With the converse triangle proportionality theorem, you are looking for a triangle with parallel lines that you prove. And then our triangle angle bisector is a triangle with a bisected angle. So hopefully this video helped you out. If you have any suggestions, feel free to give me your feedback. And let me know if anything is confusing.